Well, let's do a Newton Raphson example for why you would need to do a Newton Raphson at all. So say we had some problem where we have to, as part of the problem, solve where this happens. X e to the x equals 1. X appears twice. Can't solve for a closed form. So I throw everything to one side. Now it's a zero finding problem, and I use Newton Raphson. Now I just have to prime it with a guess. So I'll try 0. That gives me a -1. If I try 1, I get e minus 1. E is 2.7. E minus 1. That's still 1.7. Negative at 0. Positive at 1. In between, it's got to be 0. So I might make initial guess halfway. So I'm going to guess 1/2 as my initial guess. There's our function we're trying to find the 0 of. Take its derivative. Product rule. Put all this information in our calculus schematic. So I'm at the point 1/2. I know the height. Plug it into the y function. I know the slope. Plug it into the y prime function. That point and slope gives me a line. And I take that line back till it hits the axis. I'm finding the 0. And I'm trying to find x1. Set up my differentials from the point I know to the point I don't. Rise over run is slope. So rise is slope times run. And I fill in what they are. And I solve for x1. Now I have x1 in terms of all the information at my point. So my initial guess, and I get my x1. Well, what's good for x1 is good for x2. So x2 only depends on the x1 information. But then x3 only depends on the x2 information. And so on and so forth. Until you want to stop. Seems like a good idea to use a spreadsheet for this. So set it up. Initial guess. Plug in my Newton's method. So function value divided by the derivative. And drag it down to have it iterate. There we go. Of course, if I was really going to do this, I wouldn't do any of this business. I'd let Wolfram Alpha do it. I go to Wolfram Alpha and I tell it to solve. Solve for the variable x in this equation. X e to the x equals 1. Bam! Done. It's the w function, of course. The w function.